Alright guys, welcome back. This is our first video in Chapter 8. We're going through 8.1, and I don't think it's really going to take a whole lot of time, but we're going over 8.1, which is inverse, sine, cosine, tangent. Okay, and what I first want to do is I want to first introduce what inverse means. Now, typically, if we had a sine function, we would have y is equal to sine x. That's just our basic standard sine function. Well, inverse sine is actually shown with a -1 here. Okay? And basically with inverse sine, that's the same as flipping the x and the y. So that's the same as x equaling sine of y. Okay? Some other instances that actually use inverse is, let's say we had y equals 3x. Okay? The inverse of this, we flip the x and the y, and we solve again for y. So x equals 3y. Now to solve for y, we divide by 3. So x over 3 equals y, and that is our inverse. Okay? Now this works for sine, cosine, and tangent. And essentially how this looks on a graph is like this. If you look at the red, that's our regular sine function. But if you look at the blue, that is our cosine function, or our inverse function. Okay? Now once again, remember, to be a function, it has to, it can't ever cross back over. It has to pass that vertical line test. So if you look here, as this goes up to here and then back down, this right here would actually kind of do the same thing. But for it to be a function, we can't do that. So it kind of has an asymptote here and here. Same thing works with cosine. Okay. Except here, once again, our asymptote's 1, -1. But instead of it crossing here, it crosses here at pi over 2. And then remember, it peaks at 1, 0, just like it peaks at 0, 1 here. X and Y flip, so it peaks at 1, 0 here. Okay? And then tangent actually looks a little interesting. Tangent, see how we have the asymptotes here and here? That is actually our asymptote for the y values here. It's the x values for the red. It's the y values for the blue. And see how this kind of goes up, and it has the asymptote at I believe it's pi over 2. Yep, at pi over 2. Here, the asymptote for this y value is pi over 2, and the bottom's negative pi over 2. Okay, so this is how the inverse works. Essentially, there is an imaginary y equals x line, this green one right here, that goes through it, and basically it's just like a mirror. Here, this point is 1.557. And then this point will be, you're going to have to take my word for it. There it is, 1.5561. Just rounded a little differently because, you know, the calculator, or the computers are dumb sometimes. But anyway, the x and y's flip position. They flipped over this y equals x line right here. Okay, I hope that makes a little bit of sense. So to actually find the okay, there we go. I can pull it back up. Cool. I learn something new every day. To find the exact value for a sine function, what we do is we know that we're using sine inverse 1, or sine to the negative 1. And let's say we want to find the exact value of sine, the inverse sine of 1. Now, to do this, we just flip the x and the y. We flip their positions. Okay? Now, let's say that we have sine, the inverse sine of 1/3. This equals y. So then we know sine y equals 1/3. With this, you're going to have to use our calculator. Okay, so all you do is you hit second sine and then type in the 1/3, and that gives you your answer. Cosine works pretty much the exact same way, and same as tangent. Okay, and the book gives examples for inverse sine, or inverse cosine, and inverse tangent as well. There's a couple problems where you want to find the exact value of each expression, which actually we're going to kind of work together tomorrow in class from your homework, and I'd like to just do that hands-on with you tomorrow, which will be Friday. So this is a short, sweet introduction to inverse. Hope it was short enough for you, and I hope you have a good day, and this makes sense tomorrow.